So welcome back to our notes for Extrema, and in example 2 we're going to look now at relative or local extrema. If you recall from the book, those are synonyms. So a relative minimum or local minimum, that's a y value at a valley on the graph where the curve changes from decreasing to increasing. Okay, so as I look at example A, and I'm trying to find a relative minimum, right? My curve comes up and then turns here at this point, negative 1.64, 2.54. Now it's decreasing, and then here at this point, negative 0.54, comma negative 0.99, it turns from decreasing to increasing, and it creates this little valley here. Now that point is not the absolute lowest point on the graph, right? This graph is going down forever, so the point here at negative 0.54 comma negative 0.99, it's relative minimum, because from this interval negative 1 to 0 it is a minimum. So we have a relative minimum of negative 0.99. Okay, and then as I continue on, now the graph is increasing, turns to decreasing. Then down here it changes from decreasing to increasing. That's going to be another relative minimum, and that relative minimum is the y value, so that's a relative min of negative 2.54. Okay, then a relative maximum is a y value at a peak, where the graph is changing from increasing to decreasing. So as I start at the negative infinity, I head up, 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 up. It's increasing, and then here at this point, negative 1.64 comma 2.54, it turns from increasing to decreasing. And so that y value of 2.54, that is a relative maximum. It's not the absolute highest point, right? It's just relative between negative 2 and negative 1 on the x-axis. It's a relative high point. So we have a relative max of positive 2.54. Then as I continue on, decreasing turns to increasing, and then here we have a point where we go from increasing to decreasing. That y value of 0.99 is another relative maximum, right? That's a maximum occurring along my x interval 0 to 1. Okay, so you'll want to pause the video and then go ahead and identify your extrema for example B, and when you're ready to check, you can turn the video back. Okay, so in example B, my graph is pointing up to positive infinity on both ends. So I know that I'm going to have, since it's both ends up, I'm going to have some kind of an absolute minimum. And when I look down here at the lowest point of my range, right, that y value would be that absolute minimum value in my range. So there is an absolute minimum of negative 3.46, right? That would be my absolute min. Okay, then I have a relative minimum here at this turning point where the graph changes from decreasing to increasing, and that y value of negative 0.69 is my relative minimum. So negative 0.69. Okay, then we have another point here on the graph where it changes from increasing to decreasing, and that point has a y value of 0.47. That's a hill, right, or a peak, so that would be a relative maximum of 0.47. It's not the absolute maximum, because this, again, the end behavior goes up to positive infinity in the y direction. It's just relative between the interval negative 1 to 0, relative max or local max. Okay, so go ahead and try A through F on your own. You can do this on scrap paper or on your whiteboard. And these are the same problems that we looked at before where we were identifying just absolute extrema. Now that we've looked at local or relative extrema, go ahead and identify all the extrema for these graphs and classify them as absolute or relative max or min. And then when you're ready to check your answers, you can turn the video back on. Okay, so in example A, this is an absolute value graph, and you can see up here its range is -infinity to 3 inclusive. So 3 is going to be an absolute maximum. There are no relative extrema in this graph. Okay, in example B, we have a 4th degree polynomial. It has an absolute maximum of 4, right? Because that doesn't go any higher. The range tops out at 4. But there is a relative minimum here at 3. Okay, so that would be our extrema for B. In example C, remember this was our graph that had vertical asymptotes at -3 and at +3, since it's a rational function, and then a horizontal asymptote here along the x-axis. Asymptotes do not count as extrema, so there is no relative minimum here at 0 because this asymptote does not count as a local extrema. But we can see where the curve changes from increasing to decreasing right here at this point 0, -1. That would be a relative maximum. It's not an absolute max because the graph is heading up to +infinity along these asymptotes, but it is relative to that interval from -1 to 1. So we have a relative max of -1 in graph C. Okay, graph D is our square root function. It has its endpoint here at -3, -2, so that y value of -2 is our absolute minimum. Okay, there are no relative extrema in the square root function. In graph E, we have a rational function with asymptotes along the x and y axis. Remember, asymptotes do not determine extrema, and so E has no relative or absolute extrema. Okay, then graph F, this is a cubic function, and it has a relative maximum here at the point 1, 0. So the y coordinate, remember, determines the extrema. So this is a relative max of 0. And then here at this turning point from decreasing to increasing at 3, -4, our y value is -4, and so we have a relative minimum of -4.